Okay, deducing the rate expression. So let's take a theoretical reaction. A plus B plus C goes to ABC, and the rate is K, something to do with the concentration of A, something to do with the concentration of B and C. And the orders of reaction with respect to those, well, let's call them X, Y, and Z. Let me write out some fake data for us to analyse. Concentrations is in molar, and rate is molar per second, or molar per unit time. We're 2 seconds. Alrighty, so looking at this second data set compared to the first, I've doubled the amount of A and the rate has stayed the same. So the order of reaction with respect to A is 0. Changing A has no effect on the rate. Now I've doubled B. The rate has doubled. So there's a directly proportional relationship. I double B, I double the rate. So the order of reaction with respect to B is 1. And moving on to C, well in this case I've doubled C compared to my initial experiment, and the rate has now gone up by double squared, so the order of reaction is 2. So that's how I think of it, double squared, it's gone up by 4. And now for the final one, well in this case I've tripled C compared to my first reaction, so it's gone up by triple squared. That's 45. The 5 also mentioned is from the first reaction, 5 molar per second. Okay, let's try another one. This time let's look at D plus E plus F, and my rate equation, rate equals K, something to do with the concentrations of D, E and F. And the order of reaction for each chemical is X, Y and Z. Alright, there's my data table. I'm going to ignore the units. Okay, this time I've doubled D and the rate has doubled. So the order of reaction with respect to D is 1. Now I've doubled D again and I doubled E and the rate's doubled. Okay. So the doubling is due to the doubling of D. The doubling of E had no effect. So E is raised to the 0. It has no effect. And finally now I've doubled D again, so that takes my 16 to 32. Changing E has no difference, and I've doubled F, and now my 32's changed to 64. Okay, so F is raised to the power 1 as well. Phew! The units can cause no end of trouble, so if you don't understand it, just learn it. I'll try and explain it. For the first order, for example, rate is Ka. Rate is measured in molar per second, and concentrations measured in molar. So therefore, since it's an equation, the units have got to be measured in per second to keep the units on the left and the right the same. For a second order equation, rate again is measured in molar per second, concentration in molar. So what does K have to have as a unit to make the equation equal? It has to be per molar per second. The M at the bottom cancels out with one of the M's at the top. The more extended version of the units is the IB's preferred way of giving it to you. Finally, for a third order reaction, adding up the individual orders of reaction gives me 3 here. And so by using the same logic, the units for K have got to be molar squared per second. Now you can write it like that, but the IB never will. They'll put it as this rather confusing looking unit there.